I am muted, or so I thought.
Please kill that. That was it. Thank you.
Yeah. All right.
All right. Okay.
Okay. That should go on.
There it is.
All right.
It's
Broadcasting. All right. Thank you, everybody, for showing up today. Welcome to our, I think it's the 5th TWed of the spring 2019 season and the nth Wednesday night talk. TWed Talks, Idea Talks, and our Pirates meetings of our spring 2019 term. Just a couple of logistical reminders. We are streaming and recording live. You're welcome to ask questions. Brenda really wants this to be an open discussion tonight, and there's lots of people here. This is wonderful. It's a big topic. But so you're welcome to ask questions. Just keep in mind that we are being recorded. And without further ado, Brenda Thomson, thank you very much.
Hello, everyone. So my presentation tonight is about, sorry. Okay. So my presentation tonight is about DARPA's explanation or explainable AI February 2019 report. It's from there's 2 task teams that have been working under DARPA's XAI. And this one in particular is from their second team, which deals with the meaning of what is explanation. So, so we're coming at it from that point. So basically, let me pull this up here. Okay. There we go. So real quickly, the agenda. I'm just basically going to kind of cover what the report is, how it's structured, and how we can actually use it. What the explainable AI program actually is, and what are some of the models that they've come up with, as well as some of the tools that they now have available.
Brenda, could I just, in the links that I sent out, or in the email I sent out, links to the report, as well as some other contextual information are provided. So if you want to look at this in detail, you can just pull up that email.
Sorry. And at the end for these slides, those links are also in the references as well. So, all right, so let's take a look at the report. For one thing, the report is 204 pages, so it's kind of a very large, long report, so it can be a little intimidating. But I just kind of want to break it down for everybody because it's not as bad as it sounds. So the executive summary, just, as every report will have. But what's important to notice is that the actual report itself is essentially 104 pages long, and the actual reading part of it is only about 55 pages. So it's worth your time and effort and the reason that even though the report fills all of these pages, the real thing is that what they do in each subsection is break down what are the relevant papers referenced in the bibliography that are relevant, are the most important ones for that particular subsection. So you'll notice there's 70 pages of bibliography. So really take the time to go and download this report because the bibliography is so wonderful that you can just go and click on the links there and get, the papers themselves for your own research. So, and the big deal too is there in the appendix, the report ends with metrics that they've come up with to measure the actual value of explainable AI. So how does that actually work? So again, it's just broken down into some sections. The ones that are kind of really stand out as on the report itself is section 4 and section 8. Section 4, of course, covers the key papers. And so once you know if you have a particular area that you need to research, you can actually just go directly to the section, find the paper, find the reference. And then Section 8 is brand new in this report. There's one prior report for this task team. And so Section 8 is all brand new, and it's actually where they brought in human participants to help evaluate whether or not an explanation was good. So the program itself, what is explainable AI? And what is DARPA doing with it, and why did they bring it in? So artificial intelligence really kind of started back in like the 70s. 50s? Okay, sorry.
In the U.S.
In the U.S., okay. And so the way DARPA is looking at it is that there's 3 generations of artificial intelligence. And the reason that this is happening now, that we've come back around to DARPA actually thinking this is important and relevant and that it needs to be occurring now, has everything to do with those generations and the onset of deep networks and machine learning. So because as those have developed, we have wound up losing the explainability that we had back in the 70s and earlier. So anyway, so this is what this started back in 2016, the explainable AI. And so this was what they were working with at the time. And what they've done is taken basically from the learned function, right? We want to move through and create an explainable model as well as an explanation interface so that the end user actually can interpret what the system is doing. We can certainly cover why, but I think most of us in the room know why an end user would need to know what the system is doing. A big part of this program, of course, is where does the explanation come from and what does explanation mean? And so, as I was saying, there's 2 teams involved here, and the team that wrote this particular report is this team here. So they talk about, they look across all of the literatures from computer science to philosophy, psychology, and try to look at how is explanation defined so that we can actually create some kind of computational theory for how and why we will explain. So the model that ultimately they came up with for explanation follows that from, basically this, colors don't show it very well, but the first line here is actually the process, right? The user receives an explanation, which revises their mental model and then enables some kind of better performance, right? Because the user then learns to trust or mistrust the system. Hopefully, once we've got a good explanation, the trust model falls into an appropriate range, and then we can appropriately use the system as well, right? So from there, all right. So the models that they themselves that they defined to work with. Let me back up a minute. So here, what they're aiming for, right, is this is the accuracy and this is explainability. And this is where we are right now, is the orange. And they're hoping, this is the goal. This is where they're assuming we are at this point, right? That we've moved things forward a little bit with explainability, but we still have quite a ways to go. And so for the deep explanation, here basically they're just using the deep learning models basically, so that for ways to make things explainable. I'll get a little bit further into this later, but the next was the interpretable models. And so this is a goal, right, is to build a more interpretable model. And projects in this category focus on supplementing the deep learning, right, by providing an explanation and making the model more interpretable. Finally, there's the model of induction, right? Model induction. There we go. So this is model agnostic. Basically, should I referenced Gunning here. I quoted Gunning without telling you who he is. But Gunning is in charge of the Explainable AI program for DARPA. So he's the go-to guy. So let's see. Anyway, so I'm not quite clear on model induction, to be honest. So let me move forward. So they've identified 2 areas in particular for explainable AI to make an influence, and those are you're either in a data analytics area or in an autonomous systems. So what did I say? Well, let me move on to, so ultimately in the end, these are, they came up with this model for measuring these metrics for measuring explanation effectiveness. Colors really don't show up. And so once you're through, all the way through the report, the program aims to essentially have these gray areas here are actually metrics that will help you decide how effective your explainability actually is.
So these are quantitative metrics you would apply to it?
They are quantitative as well as qualitative. So they're expecting a little bit of human interaction on this. It is not strictly within the AI system itself.
This is subjective.
Yeah. Yes. So, and as I pointed out earlier, so this is where, this is the performance versus explainability metric that they're working towards. They're calling it tomorrow in this graphic, but it really is, what we're aiming for, because there's about 2.5 years left on this program. That's what they're saying right now. And so to do that, this is their end goals, right? To create a suite of new or modified machine learning techniques to produce explainable models that, when combined with effective explanation techniques, enables end users to understand, appropriately trust, and effectively manage the emerging generation, right? So hopefully. So this is what that end, at the end of the report, this is what they came up with as the metrics and what an actual report looks like. So for each individual structure, so there's about, I want to say there was 70 pages of this. So different AI systems that they have evaluated, both using AI as well as, this was the big part of Section 8 of the report that's new for this year, is, they used humans to actually evaluate the systems, and they measured how much they trusted the system, how wonderful they thought the explanation was or not. And so this manipulation of explanation goodness is kind of a tough metric to measure. So it's quite subjective. And out of all of it, the thing that's most clearly defined is what is trust. And to do that, it's really, it depends on whether you're talking to experts or are you talking to, in the case of medical, if you're talking to an end user, as opposed to the doctor, right? So a doctor expects a different set of explanations as opposed to the patient. So, different levels of trust for the different end user.
So did they develop a coding for each of these, or?
They have not yet. That is coming. That's part of the next 2.5 years. Yeah. They have, what they've done right now is just create the metrics.
Okay.
So these are going to be probably not very readable. That's a shame. Okay.
They're nicely readable online.
Okay, good. So the first model here is what Johnson & Johnson developed. So these are, see if we can explain it. But anyway, so you've got your, these are expert systems, right? So you've got your, I can't even read it on my own screen. So you move from the experts, right? Where you have, the learner already has existing knowledge. You cover the gaps, and you have just declarative knowledge as well as versus procedural knowledge, and essentially moving towards, is the explainer satisfied? This is the big metric that we're looking for, right? You have to find that satisfaction level. And it's easier to satisfy the expert on an expert systems. You know, your, what do I want to say here? So your expert, go ahead. Your expert is not, okay, well, I'll come back.
So this
Okay,
is modeling the
right?
explainer interacting with the learner.
Correct.
Okay.
Thank you. So model of the explanation of a procedure. We'll let that slide. Next comes the Kroll model. And this one was, can't see it on the corner there, but it's about events, right? What's that?
It says event occurs.
Yeah, the event occurs. Then you move to the event is noticed, then interpreted. Then you have your initial explanation, right? And so from the initial explanation, you move to the evaluation of that explanation, and then on, and that explanation originally then sets an expectation of what to expect from the system, and it feeds back. It through the process stops over here, and it feeds back to the evaluation.
So before you leave this is a generic explanation model.
Generic
So
explanation.
this is part of the big.
Oh, hello. Thanks.
Don't update right now.
Yeah. Can't even see it. That's what's great. Oh, there it is. Let me turn that off.
So this is.
No! Stop!
What happens when you have Microsoft?
Why
Right?
spoil a Mac with the?
Okay. I can't find
So
it.
you
And
actually
you
can't.
can just scroll over to the other screen. Move it over to the
Oh.
other screen.
Yeah,
Okay, good idea.
Yeah, cancel or it'll never go away.
There we go. Okay, we're still on that. Let me pull that back up on my screen. Or not. There we go. Okay. So, yes, so these are the generic models, right? That's where
So
we're at.
what's an event here?
That I actually do not know.
Wow.
I was curious about what they meant about intuitive versus deliberative in this case.
Well, I think that might be about the type of model. So a deep learning system might be providing intuitive explanation, whereas a logical reasoner might be
I see.
providing.
I was thinking about it in the terms of the explanation provided, like whether it's natural language or it's trying to trace a path of the
This is
decision tree that it's
Where's
following.
my,
I
hold on.
was thinking about it in that sense. But
Could also
yeah, that
be-
makes sense. Yeah.
So we should be careful. This is why I asked the question before. Is this a generic model or is this a specific to AI explanation? Is this a generic model of explanation? You know, are we
These are ones, yes, they were created for explanation in AI.
Okay.
Because it doesn't say much about like the outputs of AI versus the model that's generated. So the predictions, classifications, models. And I'm not seeing any of that.
Yeah.
So just to be clear, what these are is just pictures of previous people's models, not models that were developed as part of XAI or even necessarily about AI. So it's just, so all of these, so I don't know which Krell whether that's
2017.
1999 paper, 26 or 14.
2014, yeah.
So again, so these are just people, psychologists who study explanation
Thank you, Jen.
and what their models are. Right, so you got to go back to those papers to see what they meant.
Okay.
Well, and some systems, including ones that I built, sometimes have a separate system for giving the explanation from actually what the reasoner's doing. So for example, if you do complicated procedures like negating the thing that you're trying to prove and then seeing if you get a contradiction, that's kind of a non-natural way to give an explanation. So you might do a separate kind of explanation system that some people might think are more intuitive.
Okay.
And
That
I'm not,
actually-
there's a whole body of literature of using the explanation reasoning, the reasoning for explanation versus the reasoning for performance.
Okay. Wow. All right. Well, I have there's a whole bunch more papers to read in this report.
Proof by education.
Yeah, that's what description logics do these days.
Okay.
So, okay, so this is a data format model of sense making, and this one I didn't even follow through at all. So, unfortunately. So, anybody familiar with that one? Might as well ask it, right?
The sense making slide doesn't make sense.
Okay, perfect. And this was all the explanation that, there's, they give these models in the report, but, there is quite a bit of explanation to them. And then I obviously should have read them more firmly. So,
Go back to that just for a second. But even if you're not able to kind of go into depth, it might be helpful for us to soak it
in. So, yeah. So information search, identify the key evidence, build an argument, and deliver a report.
So Brenda, you used the example that maybe a physician versus a patient, the system will give them a different level of explanation.
Right.
But how does the system know who the user is?
Well, I say again, that's that human-computer interaction. So the doctor isn't going to be using the same interface that you would give to an end user, right? To a patient. Right, so it really is that the human-computer interaction and the user interface that matters.
If the backend system derives explanation somehow, it'll derive a different set of explanations. Maybe a different.
So remember there were those two boxes, the explanation box and the explanation interface. So at least in the XAI program, they would differentiate those so that something technical would be delivered, and then you would present it differently to different people based on the user model. Whether that, again, I don't know whether, I'm guessing this is yet another older model.
Yes.
But
Yeah, Pirelli card.
Go back to the one that had that learner, that first.
Some of this,
So
much of this
that you
comes
have-
directly out of AI people trying to present to generals.
Yes.
Yes.
I'm in there.
Just-
You had the one that
Trying
had the
to
explainer and the
explain
learner.
Yeah.
This doesn't.
Oh, the
This
list of
this
those.
is confused about this. This is identifying evidence to build an argument through this, but
No,
this
one.
references the explanation for how it built that part.
Four.
No, I was looking at the Pirelli model and I was confused as to its purpose in the bigger picture, but why it was important, because it's using evidence, searching for it, identifying evidence to build a hypothesis.
Right.
But nowhere in that figure was it mentioned, like whether it validated why the hypothesis was built based on certain evidence, whether it explained why that hypothesis was built. Was that not the intention of that model?
Again, this is the psychology models, right? Of explanation, not the AI.
Yes.
Right.
It was so sense making. I couldn't even in the psychological sense try to relate it to what explanation it was offering me in that model.
So sense making is, I'm sitting here and I see Brenda point at a slide, and I say, why did Brenda point to the slide? Or she asked me why did Brenda, and I say, well, Brenda is presenting, so the explanation is to make sense of the event, as opposed to the explanation is to describe what was happening in the psychological. So in other words, you can be taught, so the difference in the literature between explanation and sense making, right, is sense making is generally considered to be triggered by an event. You were asking what an event is before. That isn't well defined, but it's anything that happens. Something in the real world, and I want to know why it happened, right? So there's not necessarily a system somewhere that's presenting it, giving me my own explanation. Oh, look, I look out the window and a tree fell down. I wonder if it's windy. Right? So sense making is more focusing on that part. Explanation is more of, I've got this black box or program or whatever, what's happening inside it? Why did it tell me my moment?
Right.
So that's kind of the traditional differentiation.
Actually,
I haven't read the report, but I assume that's what they're following.
Yes.
I'm going to raise something that I asked Deborah before. In a situation like that, what's the difference between explanation of a black box system and rationalization in the sense that humans will rationalize decisions?
Right.
Possibly
So
rationalize.
at the moment, at least the things we're looking at are not distinguishable.
Okay.
right?
Right.
I assume later in the report, when they get to their proposals, conclusions, et cetera, that's where you'll see this. I think you hold that question and see if we still have it. I haven't read the report, I just have a background in some of this.
Well, it's
Yeah.
like-
That helps a lot.
So I've read a lot of
Yeah,
these
exactly
old
what-
reports, right?
Yeah.
I used
Exactly
to
what I
have
was
to
hoping
teach this
for.
stuff.
And actually, I taught Gunny about explanation.
Yeah, exactly.
Because I ran millions of dollars of DARPA money to explain his programs on AI systems.
Okay.
On the high performance knowledge base program, the rapid knowledge formation program, and some others.
So, yep.
And
That's what I
integrative
was hoping
learning,
for,
yeah.
that there'd be experts in the room to actually to have this discussion.
To contextualize.
Contextualize it, yes. So let's move towards the tools that have actually come out as a result of the work that they're doing. Right now, there's 3. I've got 2 to show. I didn't find the RISE one that Gunning in particular talked about, and that's through Boston University. If you want to go take a peek, they have this sequence to sequence visualization. Anyway, so a visual debugging tool, right? So, and basically it's a visual representation, sorry, that's so small, of different stages of the sequence to sequence translation process. So just as an example, let's see if this comes up here. Where'd my Google thing go? Nope, wrong one. 2,000 tabs open. Don't look. Nope. There it is. Okay. Oh,
You're
hi.
saying we're not doing that, and we don't have anything.
You don't have anything? All right,
Yeah,
let me.
This is the trick, you can't always use programming.
I
Yeah,
thought I thought she was, yeah.
yeah, I am actually.
PowerPoint will mess with it.
Yeah, oh, there you go.
Yeah.
Oh, there we go.
There we go.
Yay.
Okay. So this is actually the sequence to sequence. Oh, really?
Reopen close tab.
Can you do
Where?
back?
File. Nope. Sorry, guys.
There we go back. Yeah, this-
I can't even see the back. Hold on. There it is. Back. Nope. Back button isn't working. Hold on. Okay, Mike. Oh, no, there's no back.
Forward.
There we
There we
go.
go.
Hooray! I really do know how to operate a computer.
To the full screen.
Full screen. Hold on.
We're pushing our luck today, aren't we?
Right? Just because we can. All right. So this is basically the sequence to sequence visual debugging tool, right? And what it's doing is translating from German to English, right? So at least what this one is showing you. So this is a tool that they're using, and it is, sorry, I can't stand up there. And it's available on GitHub, and you can download this and use it. But what it's doing is it's showing you how things are flowing through the network, through the deep learning model. And I have a better visualization of this.
Like language translation?
It's specific to language translation. So, so there is, right? So it's showing you here in this zone, like where. Okay, so you choose which decision point you want to look at and how it got there, and you move through here, and it shows you where it has moved the decision points from, or made the decision where it made those decisions off of what data points it made that decision from, and then it literally, so it'll break down from its text, where it'll highlight that for you, show you all of the steps that it moves through. So it's a pretty nice tool if you're dealing with text and text translation. The other tool, let's see if
Who
I
did
can.
it? You know?
That one, I should know that.
That shows the authors.
Yeah, so back over here. Yeah, up at the top. There you go. So, and again, this is provided in the link to this. It's on the slide, but and then it is. There you go. It's out of MIT and IBM. So I don't think it's due to be published or it has been. I don't think that was, no, okay, April of 18. So, okay. It did
It's not preprint.
preprint. There we go. That's what I thought. Okay, let me try the other one, see if I can get it to pop over there. The next one, most of you may have heard of this one. It's from Google, the What If tool. Boink. Right. So code-free probing of machine learning. I think this was something you mentioned, Shweta, that your classmates were using for being able to move through, using TensorFlow. You choose your data points, and then you can actually do the counterfactuals as well to determine what it has, what happens if I choose this as opposed to that. And
it's modeling causality.
Causality, yeah. So it's literally a what if, as in, what if this were here as opposed to there? What if, I said yes instead of no? So you just use your, it's literally 4 facets. In case you did not see that, so you can.
Wait, 4 facets? What are the 4?
Yeah, can you make
Oh.
that screenshot bigger?
What's that?
The image.
Make this the screenshot bigger. Maybe you might be able to click on it.
Yeah, let's see. There you go. That help?
A little bit.
So sorry, what are the 4 facets?
No, it's 4 facets. Like think of it like a faceted
it's
viewer.
FOR.
Yeah,
Okay.
FOR. Yeah. Like
FOR.
faceted
I'm like,
viewers.
What are they? I wanna
Pick
see
your
them. Okay,
ontological.
got
So
it.
You can generate like multiple paths basically. This
Yes.
is like a alternate world builder kind of thing that people have done.
even just data points. It's not even. You can use it across many different types of data sets.
I see.
You can. So if you've got, like think of your network graphs, right? Your edges, right? You could move the edges around if you wanted to, and generate different, and find out what if the value is this, that sort of thing.
You can only permute the input, or, you permute internal nodes.
As far as I know, it's the inputs.
So to give you an example of that, for years ago in the early days, so for example, bank votes have been being made, decisions have been being made by neural nets for how long, Kristen? 30 years now? 40 years?
Long time.
She met with the guy who does it.
Yeah.
But then they have to give you an explanation. So what they do is they say, okay, the credit score was 625. What if it had been 650? The income was 50,000. What if it had been 75,000? So they would run it again, essentially, with permuting those. And then once it got one that said, you would have gotten a loan if, then they would produce as the explanation, you didn't have enough income and your credit score was. And was that really what went on inside the black box? We don't know. But it was actually judged legally to be this was actually went to court. It was judged to be an acceptable explanation.
Yeah, because it used to be you got a 17
Yeah.
on the score, whatever that means.
17 of what?
This seems
Anyway.
similar to something I saw at US2TS where a group from UIUC was working on a alternate world builder using semantic technologies, where they had, if this person died here, was born here and died here, what if this person didn't die here? How would it affect events happening in the world that was built? And using reasoning for tracing back to those explanations. It seems like a numerical version of that.
But again, the idea,
Yeah,
but if you can only
interesting.
permute the inputs, then that's what I was saying. So in other words, you ran the system and it said no. And now you said, okay, what if input number 13 had been 6 instead of 5? Okay, now it said yes. Okay, there was clearly a relationship between that input and the answer. So this allows you to do black box testing of its input.
Yes.
If you can actually get down inside, then it becomes a much more interesting case, because now you can say, supposing at level 3, we had changed this thing, but no one is exactly sure.
And still through everything, they still haven't come up with the solution for, right? And I'll show you.
So again, I'm not sure that's what this is doing, but that's probably the framework.
Yes. Okay, let's take one more. Okay, this.
Are those only work with the types of questions you're willing to ask.
Well, you're permuting the input.
Yeah.
So
Yeah.
whether if it's a user-facing thing, yes.
Well,
But if I'm debugging my system, and I'm saying, okay, in the face rec system, supposing feature 22 would hide, right? And
What does that do?
I don't even know what that needs to be a permissible. That's just the set of inputs is an encoding of the problem for a neural network running. So you're manipulating the input.
Let's see on what. So this, let's see if I can. Okay. So this one is from one of the. It's the learning how AI makes decisions, and what. Oh, this is the RISE app.
This is right.
This is RISE. Yeah. Okay, I did find it. So what they're doing here is they're stopping. They're basically saying, "Hold on. When you had this decision point, what were you focused on? What was the data points you were looking at?" And so in this particular case, what it's showing you is that, so this is a white sheep. This is a brown, they're calling it brown sheep, right? And here you see, so when it made the decision, is it a sheep? Is this a sheep? It was focused on this one, right? On this model. And then based on training data, it had decided that the brown sheep was a cow. And so what they're saying is that when you have this, when you're using this kind of thing as an explanation, what this kind of tells you at this point is that you haven't done enough training on brown sheep. So it can't, so it doesn't identify brown sheep, but it's also, using heat maps to explain what it was focused on is actually, as you can see, is pretty effective. So, just getting these simple explanations out, this is, bird 100%, it sees that, 39% chance that there's a person here. And then it sees that this one is a bird, but that one is a person, right? So again, it's making those, it's showing you where its decision points are using a heat map, which is pretty effective. I think you could use that in a lot of different ways. But again, RISE is out of Boston University. So I didn't have the time actually to go and find out, it's more publicly available elsewhere, but it is a pretty effective. See if I can.
And I think it was developed before this program.
Yeah.
Yes. Oh, was it?
Randomized input sampling for explanation of black box models. That's what RISE stands for.
Okay. Did have that somewhere. Let's see if I can get this back up. Okay. So I showed, okay, the what if model we went through from Google. And then, so David Gunning, I think this is a really effective quote when looking across this report as a whole. If you put a long pause here, that wait, it's the other programs that are really dealing with things outside of explainability. So if you're, this report is not the end all be all, right? You need to look across other programs. That's probably a word of caution more than anything. So I'll show you real quickly as I move ahead a little bit.
So like if you took something like that Google what if, and took all of their metrics to come up with, could you apply those metrics to Google what if? Is that like the...
That's a great question. I suppose you could. I don't, but I don't. Yeah, I was going to say, I'm not sure how long that system's going to stay up if you do that.
Well, they say
It's
the
gonna be
first phase is 18 months. I mean, I don't think
Right.
Google is funded onto this. But,
No.
But they're all going to have to evaluate their systems at 18 months.
At 18 months,
Presumably using those metrics.
yes. Correct, yeah. And did I come back to?
Yeah, we're close.
Yeah,
I'm
yes.
reading an
So that was the
article
point
from
of this-
January, and they said they're on the run up. January of this year, they're on the run up to that 18-month trial.
Right, yeah. So this particular report is like an 18-month marker for certainly for the task team too, and obviously for the whole program. But yeah, this was the 18-month marker for that. So
Oh, okay, but the evaluation hasn't been done yet? Yeah, I'm hunting to try to get the 12 awardees. I haven't found it yet.
Oh yeah, there was something in the PC Mag article.
That says the 12?
Uh,
'Cause there's
it
something that
mentions
mentions a few.
right. It mentions a few, but it doesn't
It
mention all
doesn't
12.
mention all 12.
No, it
Yeah,
does not.
Right, that's okay.
Yeah. No, you're not crazy on that one. It is actually, yeah. They mentioned that there's 12 awardees, but no. At this point, I was going to show basically some of the references, but I wanted to real quickly reference here too. So finally in the what they do is the awardees are, so what they have at the end of the report actually is what each, the universities here or, the individuals, right? There's, what each one is working on. So it literally is like how they're doing explainable models, the explanation interface, and the problem or challenge that they're answering, right? And so in the report, there is pages and pages and pages explaining. So if you need some models to work with, if you need, these sort of things, they're in there, right? Really great stuff. Yeah. Sorry, there you go. So the first probably 70 pages of the report is honestly the literature on what is explanation and trying to honestly come up with a really concise computational explanation of what explanation is. So anyway, so it's pages and pages and pages, to be honest. You have, let me go back. There we go, this way.
Oh, that's just these authors, okay.
Yeah, so these are what is the focus at these universities or, right? But this is the program itself, right? So define an explainable model, find an explanation interface, develop it based on autonomy and an autonomous system versus, data analytics system. And what are. So this is, it's there in the report. I highly recommend this part of it in particular.
But in the report, they don't mention the awardees either.
No, they don't either. I say, actually, let me see if I might have something where let me see. Nope, I closed it. All right. I might actually have one graphic that I think I saw that on. So I can look across that.
What do you mean by the difference of autonomous system and data analytics?
So an autonomous system is going to be a lot of the Department of Defense stuff or the self-driving cars, so where those kind of systems actually have like a limited or, just on-site limited resources, right, to use. A data analytics system could really be connected quite well, right? So an autonomous system is going to be self-contained within whatever, piece of hardware it's in. May not have direct access to. So, the data analytics, I think hopefully most of us know. So anything that would be able to be connected to the internet to, we would analyze those systems. More analytic power. So with that, I think we should probably have some more discussion on, what else is in the report or what explanation means and how we're going to use this.
Did the report mention how to quantify or measure explainability?
That's kind of the purpose of the first 70 pages. Yeah.
Yeah, that was in our first slide.
Yeah, it really, it's.
I'm curious as to the rise part with the it shows the images and this is the important part of the image and so on. Have they explained why it's satisfactory as an explanation mechanism? Because I personally feel that, AlphaGo uses that for showing, this is why I played a stone here, but many people have said that's not enough of an explanation for why you played a stone on a particular point. versus like highlighting this area which is supposed to be an important part. So I'm curious to say if they've given any explanation as to why that's a satisfactory explanation for why a certain decision was made, why that's a cow or a sheep or something. You know, I don't find it satisfactory enough or something like that. Yeah.
That's a good question. Yep.
That kind of relates back.
What was that?
That kind of relates back to the previous question of like, how can you quantify it?
And I say that's the problem that still it still really remains. It has not been, there is not one definition that they've settled on for explanation. You know, there's not there's 70 pages of what an explanation is, and it is really something that they hope to come to, like some concise definition is what they're hoping to come to for what it means in terms of computational theory. And they just haven't done that yet. I don't know that
I don't
it's.
predict they're not going to. Because in reality, explanation is kind of in the eyes of the beholder, and it's very context sensitive.
Yes, and they, you know, they start the report off by mentioning in the executive summary that, you know, if you know, really want to know what an explanation is, it encompasses all of Western philosophy and Western writings, from, you know, so pick your spot, and that's kind of where it is.
I just emailed you a link to the program announcement in 2016, and that shows, that provides a timeline.
Oh, there's a timeline in their 2017 report, and actually in their 2017 report, I finally found the awardees, all 12 of them. But there is a timeline, there's a more detailed timeline in the 2017 report. I read the BAA because the broad area announcement, the original call for the program.
Okay.
If you Google on XAI awardees, the guy from UMass who won is top, and then there's the announcement, and none of this stuff is you have to actually look specifically for
this report.
Yeah, although a number of your slides were actually in that first announcement.
Yeah, so I'll send you the 2017. Actually, that's on one of the pages that you linked to. The 2017 update has actually the awardees and a very detailed timeline.
Ah, okay.
Super Gantt chart.
Gantt chart. Okay.
Yeah.
We can look at that.
So Brenda,
your tax dollars at work.
Yeah.
So I guess when we hear the term explainable AI, in general, we're talking about machine learning.
Especially
today.
Right now, today where we're at, they're calling it the third generation, and of AI, of explainable AI. Actually, this is the third generation. So first generation.
Expert systems was that?
Expert systems. Yep. And then knowledge-based tutors was the second generation, and then there's defining an explainability winter that happened basically from 1995 until 2013. So there was nothing really published on explainable AI. Then that's what they're using as publications.
Was published in 1996, and they reference it. Well, they reference the internet paper.
Well, I was going to say, so in this small graphic, this might be yours right here.
Or maybe it was a resurrection of explainability Easter.
I checked to see whether the report included my question.
Yes.
The first thing we all do.
So in the how they explain the explainability winter is it's the time when there has been the rise of deep learning and machine learning, right? So deep networks, machine learning, generative networks, right? So all of that has occurred. So in building that, we as researchers, right, kind of abandoned the explainability, and we're okay with working through, right, and that's their explanation. And then so now we're at this point where it's kind of an inflection point, and we have to really get back to looking and being able to explain what our deep learning is doing now.
And maybe semantics comes to that.
That's I'm thinking absolutely, yeah, semantics, yeah. I think there might be an expert on maybe some decision logics in the room, but yeah, that's going to be really important. Yes.
Is explainable AI more focused on the how question rather than why question?
Can you repeat the question?
Yes. So the question was, is explainable AI acting more on the how question or the why question? And it seems to be that they're really looking towards the end user, whether that end user is an expert or, just a, one of us, or, who may not be an expert, right? So, it's looking across what that means. It's not really focused on how, but except maybe in an expert system where the expert tells them what it needs to do. And then it's kind of more focused on the why for the for a less, I don't know how to. Yeah, the end user. Yeah, it's just, so it does look across all of those questions.
So this timeline is going all the way out to mid-2021. So we're in sort of the analyze results phase right now.
Yeah, they're saying
Yeah,
2.5
we're in the end of
years.
phase 1.
Been starting state phase 2, right? That was my.
We are prepped for eval 2. Unless it's, I'm looking at an older one. So this is
Yeah.
Oh, you're looking
multi-year,
at from the call?
I'm looking from the call.
Oh,
Yeah.
okay. Well, this was kind of one of the things that I kind of tried to look across when I was just even reading through the report, with some signs of scope creep, and just as project management, right? And they really did a great job of defining themselves on the first go round, and they haven't, at least in published reports, they haven't had a lot of scope creep. They've stayed focused on what they originally intended to do.
The updated one goes through May of 2021.
And they're saying 2.5 years. That would be correct?
Yeah, phase 2 goes from February of 2019 through May of 2021.
So here's a question. How do they future-proof this program, given the amount of change that's going to happen just fundamentally in machine learning in the next couple of years?
Well, one of the things that they did that was good, I mean, you can debate those metrics, but they made a stab at criteria for evaluation. That was good. I'm not sure how easy it is to give those numbers.
So I know that they've got several breaks in a cycle. There's like these phases in the phases, right? But I guess what I'm just kind of wondering is will they be able to respond to externalities? Is it kind of relying on the players keeping up and keeping their position and innovating? I guess that's what they're paying them to do.
Yeah, well, I think if the world demands those metrics to be satisfied, then people who rise to the top are going to start making systems that address those metrics. We could debate whether those metrics are actually all that good or easy to evaluate, but it's a start. And my guess is this is near to the end of Gunning's career at DARPA. He's got machine common sense, and maybe that's his last program. So in some ways, it's the next person who cares.
Well, and the people we know are pretty sharp anyway. So
yeah, I mean, I was looking at the PIs who were awarded; they're pretty impressive.
So it's 7. Why don't we thank Brenda? Thank you very much, and thank yourselves for showing up. This is one of our rare occasions when we have a full room and it's not lightning talks. So speaking of which, for those of you who are Tetherless World, we're going to start soliciting for the end of the term. It's the last day of the term, or last Wednesday of the term is going to be our lightning talks, and we're looking forward to that. So
sorry, which day is that?
it's Wednesday, last day of the term.
What date?